Okay, hi learners, we're back here with the second video for constructions. The last time I stopped here, a congruency of triangles. We mentioned that congruent triangles are exactly the same. So in this activities, I told you I'm not really going to do this. I'm going to be trying to save some time. Yeah, I'm going to be trying to save some time here. So, okay, so I've already shown you that how to draw a triangle. I've already shown you how to draw the triangle. So the same thing, same concepts apply here. So you would have had to draw this triangle here and draw this triangle here, namely ABC and DEF. You would have drawn that, and then they would have asked you to measure the angles, and you would have seen that the angles are going to be equal to each other. So if the sides are all equal, all the same, and if the angles are all the same, those two triangles are exactly the same. And we said that if the triangles are exactly the same, they are congruent. All right. So yes, I'm not going to teach you right now how to name the triangles, how to look at the different angles, etc. For now, we just need the concept as to the triangles will be exactly the same. That lesson will come a bit later on in the next, I think it's in the next section or next two sections. So yes, so that's what activity 1 is asking you for. If they're asking you to draw this out, and then we're going to measure the angles, and you're going to see that they are exactly the same. Now, yes, I do want you to do this in your workbooks. Let's look at activity 2. Now, activity 2 is the second case, side angle angle. Side angle angle. The first case we dealt with was side side side. We can see that the sides are all the same, and we mentioned that in this investigation we made you measure the angles, and you're going to see that the angles are exactly the same, and therefore both the triangles were exactly the same. Now we're looking at side angle angle. We have a side here of 8, and here's the 8, so that's 1, that's our S, our side. Then then we have this angle 45, there's a 45 angle, there's a 30, there's a 30. So they're going to ask you to measure C, right? We already know, let me just try and get a calculator. Right, we already know that we're going to have 180 minus 30 minus 40. What happened there? 180 minus 30 minus 45. There we go. Is 105. Right? We already know that internal angle of a triangle, this would have been 105. This here would have been 105. So that's what they're asking you. They're asking you to construct this, and you physically measure that this is your 105. This is your 105. So what they're going to do is they're going to also ask you to measure these lines. You're going to find out that CB is same as EF. Let me just write that down. You're going to find out that this line is equal to this line. Why is that still there? Okay. Right. You're going to find out that, okay, obviously 8 is equal to 8, and you're going to find out that this line is equal to this line. When they ask you to do all of this stuff here, to measure these lines, you're going to realize that these lines are exactly the same, and you're going to then conclude that this triangle ABC is exactly the same as DEF. Right? Then, the third case, side angle side. Here's my side 7, 7. Another side 9, 9. And there's my angle 60, 60. Can you see that? Then they can ask you to measure this angle, B. There we go. Measure angle B. You would measure angle B. You would measure angle C. You will also see 8 to 9. Let me see. That angle B would equal to angle E, right? You will also see that angle C is equal to angle F. right? When you do draw this, and when you measure using your protractor, you will measure and you will see that these angles equal, and they'll also ask you to measure this line here, the CB and this EF, and you realize that CB and EF are exactly the same, and you're going to conclude that this triangle is exactly the same as that triangle there. Fourth case, right angle, hypotenuse. There's it. Right angle triangle, hypotenuse. Okay, right angle, hypotenuse, and a side. Right? What is my hypotenuse? It's opposite my right angle. So opposite my right angle, this here is my hypotenuse. Opposite my right angle, this here is my hypotenuse. I can see that the hypotenuse is the same. Right? Okay, we've already realized that this triangle has a right angle. This triangle has a right angle. So this R is sorted out. We then looking at our hypotenuse. There's a hypotenuse. They're the same. We're looking for a side that's also the same. 6, 6. Sorted out. Then they're gonna ask you now. You all of this. Measure your other angles. Measure that angle. Measure that angle. Measure this angle. Measure this angle. Angle A, C, D, and F. Right? And you're gonna realize that the angles are corresponding, right? You can realize that D corresponds with, let me see which one, A, right? You're going to realize that C corresponds with F, meaning C is equal to F. If this is 30, that is 30, right? You're going to realize that, and you're going to come to a conclusion that this triangle is exactly the same as that triangle there. We said we're skipping that. Conclusion. Okay, I think in my last video I mentioned that we need to know our cases of congruency. Our cases of congruency, right? There's only 4, and there's a 4. Later on we will be doing the similar triangles, and that's another discussion, right? So in this video we are tackling construction of quadrilaterals, right? Construction of quadrilaterals. Now, many learners I know do have trouble drawing this out, so let's try and sort that out now. The first one, the parallelogram. Construct a parallelogram. I'm just going to write on my sheet some notes so we can switch the screen off and go to the next one, right? So let me open a textbook. Okay, so I've got my textbook out here with me. You should have this open as well, and so you can look at what I'm talking about, right? So if not, maybe you can just rewind to this video. Let's go. Yeah, okay. So let me try and centralize that. Maybe open it up a little bit. There we go. Okay, let's do this here now, right? So the parallelogram, right? Activity 1 says construct a parallelogram PQRS with Q equals 30 degrees. Let's just start with it, right? So let's see. We got QR was 6. QR was was 6. Let's see. We also had a 30 degrees happening here. Okay, 30 degrees. How do we construct the 30? Let's remember. There. That's a 60. Sorry. That's a 60. 30. Bisect that. Don't think so you can see that, but anyways, okay, in the last video you've seen that I've constructed the 30 degree angle, right? So that's my 30 degrees. They said that this next line is 4 centimeters long, so we're going to open up to 4 centimeters. Let's check that, get a bit more accurate. There we go. So we drew that there, 4 centimeters. So in pencil we can extend this line here. Let's check this out. Right. Now where this line met my 4 centimeter, I hope you can see my 4 centimeter is here, that arc there. Where that met is here. So my line, actual line, is gonna stop here. There we go. Right. Then yes, you can go and construct another 30-degree line here, but I'm just going to use a different method that we use in EGD, sliding set square technique. Let me just get this. Right. Okay, let me show you one time. Right, this is generally shown in EGD, but anyways, I think you can benefit from it. Just put something solid next to this set square, right? So what you're doing is we're putting parallel lines. We know that this this line is going to be parallel. This is how my parallelogram is going to come out, right? So this line is going to be parallel to that line. So I get this here exact to that line. I put something solid here so I can slide. I go top there, right? Construction line. Okay, same story. Let me try and just put this in here. Okay, so I'm working with a cramped space here. Okay, there we go. Right. So anyways, now I have constructed this parallelogram. This would have been P and this would have been S, right? And I've got my 30 degrees. The next B asks us measure all the angles and sides. What can you conclude? Let's check it out. If you measure here, we know that this was 6 centimeters. Measure here, this was 4 centimeters. Some glasses on the way. Okay, let's measure this PS. PS is 6 centimeters. RS 4 centimeters. Right? So they asked us to measure all the sides and angles. Okay, what can we conclude? What can we conclude? We can conclude that this side is equal to this side. We can also conclude that that side is equal to that side. They then ask us to draw our diagonals. Maybe let's use a different color pen. Okay, we got a different color pen. It's working. Alright, then we can be drawing in our diagonals. Draw that diagonal there. Show this diagonal here. Alright. So when you're gonna measure, okay, let's measure. Let's look at this. Where is this? 15, 16, 17, 6. Okay, it's about 16. Yeah, there we go. This is 16. This is 16 millimeters. Can you see that? What can we conclude? That this is equal to this. And when we measure from here to here and from here to here, we're gonna realize that this is equal to this. That sorts out our parallelogram, right? Let me just clear up a little bit here. Okay, there we go. That sorts out our parallelogram. Let's go on to the next one. Right, rhombus. Rhombus. So I'm just gonna go straight to this rhombus, right? I'm just gonna go straight into this rhombus. Okay, I'm just gonna, okay, just for time's sake, right? This is taking quite a lot of time. I'm gonna be doing just the rhombus. Actually the rhombus and the parallelogram are the hardest ones from this activity that we're going to do. I'm just going to do that, and then I'm going to explain. I'm just going to verbally explain you the rest of it, right? Yeah, okay, the rhombus. Let's get to it. So we're done there. Let's go to the rhombus. Come on. Okay, rhombus. Right, this way here they tell us that this is 5 centimeters. Let's leave some space there. Okay, this is 5. You know, I think we'd rather zoom in. This could help us. Yeah, and that'll be better. Okay, sorry, here we go. This is 5 centimeters. They call this BC. They then constructed a 60-degree suitable radius, right? Suitable radius. Come here, cut where it intersects. There we go. Draw your construction line here. Oops, sorry, a little bit off there. Extend that line. Then how long should that line be? Let's see, 5 centimeters. Let's measure 5 centimeters. Here to here is 5. All right, there we go. I've measured 5 centimeters there. Then yes, you can put another 60-degree line. Let's tighten up here. Another 60-degree line. No, let's just move it further. It'll be much faster. Okay, just there exactly. It's hard to work in a small space. Okay, got it there exactly. Sliding set square. Let me just extend this line. Alright, so anyways, we got that there. We extended that line. Let's see to how much we need that. We said 5 centimeters, right? Right. Then we can just join our top. Remember, if you cannot do the sliding set square technique, just draw another 60-degree line here, right? So we completed that. They call this A and D. A and D. Right, we said this was 60 degrees. We said this was 5 centimeters. We actually measured that. This was 5 centimeters. Measure all the angles. Measure all the angles, right? If we measure here, excuse me. Oh, can't get this straight. Why? There we go. If you measure that, it is 60 degrees. Oh, we can't see that. We got a glare. 60 degrees, right? So this is 60 degrees. If we measure angle C, if we measure angle C, we're gonna see that angle C, let me just, sorry, I'm just getting it exact, is 120. I can't see that. Sorry. Angle C is 120 degrees, right? And if you measure my angle A, you get 120 degrees as well. So what can we conclude? We can conclude that opposite angles are equal. Can you see that? Can you see this way? 120 degrees, 120 degrees, 60, 60. Yeah. So then the next part of the question says, you know what? Construct some diagonals. So we construct some diagonals. There we go. Right, we constructed the diagonals, and then they say, you know what? Call this intersection E. You know, where everything crosses, where they come together, the intersection. They call that E. So they tell you name it E1, 2, 3, and E4. Right? So we named it E1, 2, 3, 4, and then they say, you know what, measure angle E1, 2, 3, and 4, right? Measure that. If you measure that, right, you're gonna see, there's a glare again, okay, but you're gonna see that this is 90 degrees. Can you see this line here is going into the 90 degrees? So you're gonna realize that this is 90 degrees. You're also gonna realize that, okay, E1 was 90 degrees, E2 90 degrees, E3 90 degrees, E4 90 degrees, and that's what they want you to conclude. They also want you to conclude that when you measure from here to here, from E to D, and from B to E, you're gonna see that they are the same. When you measure from here to here, they are the same. From here to here, they are the same as well. Right? Sorry. I'm supposed to say that this is equal to this, and this, sorry, 2 slashes, and this is equal to this. Making many videos today, so my brain is getting tired. So we've got those diagonals are equal, and these diagonals here are equal, right? As you move on and you get more advanced, you're going to realize that you're going to be using words like the diagonals were bisected, meaning that this is what you call a diagonal. It was bisected, broken exactly in half. Same story here, but this diagonal here was broken in half. It was bisected, right? So that's your rhombus. Let's get back to our worksheet, because I don't want this specific video to be too long, because we need to get in more detailed stuff, right? Okay, construct a rectangle, right? You would have constructed this rectangle, whether you use in this specific section, whether you use a protractor or whether you use your construction method to get this 90 degree, it's up to you at this point, right? Yeah, in technologies they actually force you to do the constructions because you get marks in there. Construction triangle. Okay, all right. Okay, so what's going to be happening here now? We've got this triangle. Let me just, okay, I just wanted to switch my camera off. I'm back now. All right, so we would have please let me know if you're having any trouble constructing this here, and I'll help. Right. So anyways, we construct this here. Measure all the angles and sides. See, I want to zoom in. Okay, there we go. All right, so I've got the book in front of me so I can read the questions out. Let's see, right, measure all. Okay, so when you draw this, they ask you to measure all the sides. So you would have measured this side, and you would have realized that this side here is equal to 7 centimeters. Let me put centimeters in small caps. There we go. You would have also realized that this side here, the right hand side, let me get that, this right hand side here is equal to, wrong one, sorry, what is it, text box. Okay, that this here is equal to 5 centimeters as well, right? All right, there we go. Right, that's equal to 5 centimeters, right? That's the first question. Next one, let's see. Triangle, draw diagonals. Okay, on a constructed triangle, draw your diagonals, right? Let's look at this, right? If you look at these diagonals now, maybe get this pen. They can ask you, what do you conclude from this? What can you conclude is that this diagonal here, I'm talking about AE, is equal to that, and you're going to see that BE, B to E is equal to ED, right? Equal. And coming back to our primary school knowledge, we know sorry, that opposite sides are equal. 1, 2, 3, 1, 2, 3. AD is equal to BC. B is equal to, and are equal. Square. Constructed the square. Obviously, we know the square. Right angle there. We're gonna realize that all sides. So this is 6. 6. It's putting evil video. There. Let's look at this. Now, once you construct this, right, then you're going to be drawing your diagonals, and you're going to realize that a similar thing happens, that these diagonals bisect each other, right? They bisect each other, and you can also realize this. So the square has they diagonals meet at a 90-degree angle. This is a 90-degree. There we go. Right. That all sides. This is how I remember it, right? This is how I remember it. What a parallelogram, right? Our diagonals, right? Our diagonals. This is that I just did with the camera. This side is longer than this side with a parallelogram. It's like a tilted rectangle, right? It's like a tilted square, right? Let's look at tilted. Okay, it's a bit tiny. All right, we know that this side is equal to this side, and this side is equal to this side. Opposite sides are equal, right? Here, we know that these sides 1, 2, 3 are tilted square. We said. Now, how I remember it, right? If we have this here, like a square, rectangle, it has a right, where we've got right angles all over the show, on all corners there. All of your diagonals are equal, right? And here with the square, same story. When we got our right angles all on all corners there, all are equal there. Also, your square and your rhombus have 90 degrees and where they intersect. Right? Let's just zoom in so you can see that. That went away. Okay, there we go. All right. Done that. Okay, the kite. All right, the kite. With the kite, you would have constructed this kite. You would have constructed this kite. All right. They would have made you construct this kite. All right. The instructions are there. 6-centimeter line, 30 degrees, go 6 centimeters out there, 3 centimeters, and 3 centimeters. You can from here draw a 3 centimeter line, circle the arc, your arc, and where they intersect will be point D. Right, you can draw that. And okay, yes, let's see what they want us to see. They want us to see that this side is equal to this side. That's what they want us to see. They want us to also see that this side is equal to this side, right? Then they ask you to draw some diagonals. Right? All of these are diagonals. All of it. all of those are right angles. I'm just gonna take it out to look a bit neat. All right. And another thing you're gonna have E and EC, that AE is equal to EC. You're gonna see that there as well. Okay, that's all for now. Yeah, see you in the next video.